you one value. And what value are they giving you? They've given you your C, which is the speed. We know that every electromagnetic wave, as a scientist should know, that every electromagnetic radiation moves with the speed of light, and that has a value of constant value of 3.0. They won't give it to you, you're expected to know, and raised power of 8 meters per second. That's the value for the speed of light. What else do we give you? We now give you the energy of the radiation, and that was given to us as E equals to 2.0 kilo electron volts. This is unit, kilo electron volts. That means you are saying it's equals to what? 2,000 electron volts. 2,000 electron volts. Okay, good. Now, constant value for Planck's constant, because we're dealing with radiation here, and we have to deal with the Planck's constant also while solving problems with emission of radiation. So we said Planck's constant has a constant value of what? 6.62. So textbook we see that 63 times 10 raised to the power minus 30. That's Planck's constant. So let's put them into this formula. Equals to hc over lambda. And now what we're looking for is the wavelength. We don't this expression. This formula can be written as wavelength equals to hc over p. So let's plot in our values. We know what h is. We're saying the wavelength of that radiation that will be produced, understand, from that pointer to be equals to 6.62 times 10 raised to the power of minus 34, which stands for Planck's constant. Then we said times c, which is the speed of light, 3.0 times 10 to the power of energy. And our energy there is what? 2,000 electron volts. Now recall, 1 electron volt is equal to what? 1.6 times 10 raised to the power of what? Minus 19 joules. I said that yesterday. You cannot operate with electron volts when you are doing the mathematical volts to joules by multiplying the electron volt given to you by this value, and that will be giving us what? 2,000 electron volts become 2,000 times 1.6 times 10 raised to the power of minus 19. So this, everything like this in joules. So with that now, we should get our value. Our lambda will now become, that will give us an answer of fixing function that is the calculator. We have 6.62 times 10 raised to the power of minus 34. Then we have times 3 times 10 raised to the power of 8. Value times 1.6 times 10 raised to the power of minus 19, negative 19. And that gives us 6.2 times 10 raised to the power minus 10 meters. That's our answer. 6.2 times 10 raised to the power of minus 10 meters. So that's our wavelength. Now, if you don't want to call it 6.2 times 10 to the power minus 10 wavelength meters, you can say 62 nanometers. That's another way of calling it, 62 nanometers. Because nano is raised to the power minus 9, you get. So, or this one now will be, or you can say 6.2 times 10 to the power minus 10 meters. So that's it. I believe that that's clear. For that aspect, I believe that that's clear. So let's go to the second one. This one we just did was what? We used E equals to hc over lambda, and we're able to postulate that since we're dealing with electromagnetic wave, those waves should be moving with what? Speed of light, and that's the value there. Then since the radiations are getting emitted from the surface, there will be an effect due to the Planck's constant. So let's now come to this next aspect. Now, one basic thing about physics is you shouldn't cram and no knowledge is lost. Every knowledge in physics is a prerequisite for other topics. Now, this topic now has been relating the energy that was produced. You get that now? They said a 5 kilogram mass. So our mass here, kilogram. A 5 kilogram mass attached to a spring of spring constant K equals to 400 Newton per meter. 400 Newton per surface with amplitude of what? 10 centimeters. Now the amplitude A number if the energy levels are constant. Now, where do we see quantum number? Just as those integers I told you yesterday that represent the quantum level, and that's in this formula, E equals to NHL. Our quantum number is this N. To make it N is something of formula, I mean N is equals to what? E over HL. But the problem now is we were not given the energy, we know H as a constant, we're not giving frequency. How do we get all those values? We have to go to those topics. Now, I'll remind you something now. Remember that in spring constant, the energy, you understand, the energy stored in the spring, since we are dealing with energy in the spring, is equal to what? 1 over 2 spring constant what? A squared, amplitude squared. And that in turn gives us 1 over 2 times, we have been given the constant as 400, so put 0.1 squared. Get that now? So 2 here 1, 2 here 200. So by the time we multiply this, for the next is frequency. We've gotten this, we want to know what this value here is, frequency, before we can get the. So how do we get the frequency? We will now recall another formula. F, frequency in spring constant is equals to what? We know it's equals to this over 2 pi. And we know that this is also equal to 1 over 2 pi square root K over N. For those of you that have been reading very fast, definitely you wouldn't have forgotten that formula. A very sweet formula. So we now have 1 all over 2 times 3.142, that is your pi, multiplied by square root K, which is what? 6.62 times 10 to the power minus 34. Yes, minus 34. We divide it by what? No, sorry. That's the value for Planck's constant. K, we've calculated K already. We were giving K 400. We're giving K 400. So 400 Newton per meter divided by the mass, which was given to us as 5. So dividing this 5 here 1, 5 here gives us 80. So we're left with F equals to 1 all over. Let me quickly do that in the calculator here. 2 times 3.142. Okay, that gives us 1 over 6.284. 6.284 square root 80. I'm saying square root 80 divided by 6.84. Into this formula here. And that will be giving us what? So that we can get our quantum level. You get, so we're saying N now is equals to E, which is 2 joules, divided by what? Divided by our frequency, that's H first, that's H, which is 6.62 times 10 raised to the power of minus 34 joules second times what? Times frequency, which is 1.423 hertz. And every 423. So yes, when you press your calculator, you should get 2.12 times 10 raised to the power of 33. That's what your value should be. That's what your value should be. So that you're having n to be equals to 2 and approximately 2. So quickly write that down. Quickly write that down. Yes. Quickly write it down. 2, or we have here 2.12 times 10 raised to the power of 33. When you press in your calculator, that's what you should get. Write it down. It's actually very easy. Know when you have to use each formula. I tell you guys, make sure every formula you have known from your first semester work, you stay up to your head. You don't know when it will relate it. This question and all the questions I wrote on the board, I adapted them from your past questions. So as you can see, they are not difficult. It's just about you being able to remember some of those things. Okay, so just for you to remember some of those things. Let's move to the next one. I don't have time at all. So the economist. Exactly, so I'm preparing for it. The resolving power of a microscope is approximately equal to that of the wavelength of the light ray. Now, please, when you are solving questions like this, be very sensitive. The resolving power of a microscope. Of a what? Microscope. And we know that the power of, okay, like in your light is equals to what? P equals to 1 over what? Our power is as good as 1 over lambda. You get it? Now, they said the resolving power of a microscope is approximately equal to that of the what? In an electron microscope, electrons are used as the light source. They are trying to tell us now that since electrons are used as the light source, I get it now, it's going to be serving as the one storing the energy. If the resolving power is required to be 10 raised to the power. So we are saying our lambda, the lambda there, as you can see, 10 raised to the power minus 11 meters. 11 meters. For is Ke. And what's the formula for Ke? Ke is equals to what? I gave you yesterday. Hc Hc all present. Since it's a light source, so we are saying our C is going to be equal to what? It's going to be equal to speed of light. So let's quickly insert everything that we have into this expression. We have this, and this is a constant. So let's just quickly do the insertion. So what do we have? We'll be having Ke equals to what? K, which is 6.62 times 10 raised to the power of minus 34 times speed of light 3.0 times 10 raised to the power of 8 divided by what? Divided by our wavelength. And what's the wavelength? 10 raised to the power of minus 11. 0.62. Jesus.